Hey y'all, it's Ms. Blasky. Starting off Unit 2 today. We're going to buzz through a couple of these topics put together because a lot of this is just sort of background and definition-y kind of things to know about bonding. So first off, we're going to talk about the different types of bonds. Two of these you should be super familiar with, one might be a little less familiar with. First type is ionic bonds. So ionic bonds occur because of the attraction between the positively charged cation and the negatively charged anion. Makes this nice, pretty organized system of positive, negative charged ions alternating back and forth. Covalent bonds happen from a sharing of electrons instead of a giving and taking like ionic do. We also have this sort of combined attraction and repulsion going on where the nucleus of this green oxygen atom is attracted to the electrons of the purple one, and the purple nucleus is attracted to the electrons of the green one. This is what we're really familiar with. We talked about this a lot last year with covalent bonds and sharing of electrons and making sure you have your octet and all that sort of good stuff. We'll get in a little bit more into that later on this unit. Metallic bonds are a little bit different. This is something you might not be as familiar with. When metals bond with each other, they don't share, they don't give and take, they all just sort of go and donate all of their electrons out into the world. So we've got these positively charged cation, metal cations that form this nice pattern, and then their valence electrons that they have given up just form what we call a sea of electrons. They're able to move around and float between those positively charged cations, creating a very easy way for electricity flow. So that helps give metals a lot of the properties that they have about being able to conduct electricity and being able to be formed into different shapes and not cracking and all that sort of stuff. While we're talking about bonds, no matter what type of bond we're talking about, ionic, covalent, metallic, if this works for all of them, bonds happen when our orbitals on the atoms overlap. We know that those electrons can hold a certain number, or those orbitals can hold a certain number of electrons. When they overlap, we get, it lowers the overall energy of the atoms. By sharing that space, it makes them more stable. Now, we can talk about this stability with what we call a potential energy graph. This graph looks sort of weird. It's a different shape than normal, but what we're seeing is that this vertical space, this is our bond energy. And this distance along here, notice this is HH distance, this is our bond length. So there is what we call a sort of sweet spot or Goldilocks spot when two atoms are coming near each other, where we maximize that amount of stability in terms of its energy, where if they move too far apart, we're actually going to break those atoms apart and have no sort of attraction between them at all. Or if we smush them too close together, then we start getting repulsion from the two nuclei pushing each other away, those two positive nuclei pushing each other away. So if we look about this top part, this is repulsion. And under zero, this negative part, this is attraction. So this sweet spot, this Goldilocks spot, where we have just the right distance between those two nuclei, so that would be the perfect bond length to give us the maximum amount of bond energy to stabilize that bond. So we can, and one of the things we're going to do in class is to see how this graph changes based on different atoms, based on the size of our atoms, based on whether our atoms can form single bonds or double bonds or triple bonds. We'll see how this graph changes with response to those. And so we'll do these practice problems in class together. Along with that idea, thinking about how bond length and bond strength correspond to each other, we can talk about this thing called bond order. So mainly when we're talking about covalent bonds, we can have single bonds, we can have double bonds, we can have triple bonds. If we have a single bond, we consider that a bond order of 1. Double bond is a bond order of 2. Triple bond is a bond order of 3. We can have bond orders that are in the middle. we could have a bond order of 1.5. And so what that means is that we've got one single bond, one double bond, and they're averaging each other out. So we'll see this happen a lot more. But that bond order, the increase in bond order, means that we are going to increase our bond strength. More electrons are being shared in a covalent bond. That's going to increase the strength. That's going to increase the attraction between those two atoms to each other. Last chapter, we were talking about the attractions inside of a single atom. Now we're going to start talking about the attractions between two atoms to each other. Even though those bond orders, as that bond order increases, we get stronger bonds, it also is going to make those bonds shorter. It's going to make those atoms pull in closer to each other. So we can still talk about Coulomb's law here. We can still talk about the increase in distance causing a decrease in force, or a decrease in distance causing an increase of attractive force between those two atoms. And again, we're going to talk a little bit more about this in class, but this is really all sort of the basic verbiage that we need to know before we can talk individually about each type of bond. So next up, we'll talk individually about ionic bonds and covalent bonds. I'll see you later.